Here we are on episode 6 of the Paul and Luke talk about Fledgeling and maybe actually do something about it this week cast.
I so I last week I said that I was going to work on um, some mechanics, which I ended up working on at like 9 o'clock last night
Okay.
instead of. So we actually did, and then I ended up calling you up and you helped me with Universal Architect, so that was cool.
Yeah.
Um, I thought it might be useful to talk through where we left off last night with Universal Architect, and I saw a couple different ways of trying to implement the role mechanics to integrate, and that might be something because then we can talk about fledgling and also maybe go somewhere.
Right. Okay. Cool. Well,
Okay, so right now, what you got with role
you want to bring up your
with
screen? You share your screen or something? And then we can
um
have it on the thing so people know what we're talking about. I know what you're talking about, probably.
okay,
And you know what you're talking about.
probably. So, well, it's just the shape of it. So
Okay.
let me just talk with my hands.
Yeah.
So
Yeah.
if we are if we have so it is an iterative approach where it looks at a node and so we talked about it last week what it was,
Hmm.
and so if you have a node and it's got its resources in it, it goes to each resource and it tries to fill in those resources by grabbing another node, and then it propagates down
Mm-hmm.
and then it does several passes through this as it looks through every basically like a tree that it's constructing by selecting from the list. And right now it's doing it discretely, which is easy.
Mm-hmm.
And um, it seems that what we would need to do to change it to a thing that rolls is that we would have to take the node, go to its resources, pull up the resource that it needs. Same same kind of um, method of
Mm-hmm.
looking through the nodes, but I would want it to look through um, a list of nodes that we have access to. Right? We
Hmm.
want because we want it to look through your inventory basically.
Yeah. Would it be looking at the current excess resources that you have?
Mm, right. Are you going to have nodes in your inventory?
Because
I
nodes
was
are.
thinking you'd
Yeah.
have like let's say you went to town and there's a well in town.
Hmm.
So as long as you're standing in town, anywhere where the well is in the local space, then the well is in your inventory. It's
Yeah.
accessible.
Or it's
You can
in
use it.
the local context or something.
Hmm.
So there would be a way of really what you're talking about is limiting access to nodes. You're not creating a new way to access nodes. You're creating a new limitation on nodes that you have to be spatially present with them in some way.
Right. So then that shouldn't be too hard because then you're just going to have like, I mean, right now it's just a text document. So our game would be adding and subtracting things from a text document of nodes.
Sure. Or I mean, the text document is just a way to tell the program what nodes are there. So it wouldn't be hard to add some sort of um, location thing or something. I'm not sure how it would work, but
I would probably do it by just having, I mean, so we don't have to do any changes.
yeah.
Just have it spin up a text document for every location.
Mm. Oh, okay. Hmm. And then you then you change locations. Okay, so here's another option. If we don't want to have an actual like 2D or 3D map of the space, we can just we can add a cost to each node, like a travel cost.
Okay.
And we'd need a way to indicate that you only pay that
Does
cost
it have a bit of distance, some
once.
distance, a lot of distance?
Well, so the problem is, yeah, the problem with I'm just thinking this through. The problem with the way that I have it implemented right now is that you'd pay the cost every time you use the node. Like every time you call the node, you'd pay that same cost. So it's like, you travel to the well to get 1 bucket of water, and then you travel to the well again to get the second bucket of water. Like, well, no, that's not how this works. Like, you should travel to the well once and get all the buckets that you need.
Right.
So we'd need some way of the old system had a way of discounting multiple uses. It also had a way of creating scaling nodes that would provide exactly the resource you need, which wouldn't be hard to do either. It's like a custom designed generator, for example, that just scales to provide exactly the power that you're asking for, instead of having it be discrete. With integers,
Right.
with integer stuff, it doesn't matter, right? Because they're all just ones. If you got something that provides one of a thing, then you can get what you need. But anyway,
Right.
so we could add some sort of thing where it allows you to have a kind of resource that is one-time use. Like you use it for you use it for gaining access to the resource, but you don't, or to the node, but you don't use it every time that it's not a cost. It's not a resource cost. It's an access cost. It's like the
And
cost of
you'd
traveling
make
to town.
and you wouldn't that just be a resource that's put into the node?
Well, right now,
It
if
would be
it's
like,
a resource in the node, then it's something that gets used up. It gets used up every time you use the node. So like, making some bread at the bakery, and you need some flour and some milk and
right.
some honey. And so you put all that stuff in and you get a bread out. And if we add a travel resource, then you have to put the travel in every time you get a bread out.
Right. So you put the travel resource. The travel resource would just be very, very small because everything's in the bakery.
Yeah. Well, ideally, it would be paid once, right? You pay the travel resource once to get to the bakery, and then you can bake as much bread as you want while you're there. So that's what I was saying. Like, we need to make a new kind of resource tag or some sort of consumption thing that let it know, hey, this is a special kind of cost for using this node that only gets paid once for gaining access to it. Like another analogous thing would be a research cost. Like, you need to research this technology, so you pay the research cost. You don't pay it every time. You pay the research cost once, and then you can use that node as much as you want.
So when we were talking last week, we talked about the first like. Okay, so here's how I would solve the problem. Yeah, so we have a bunch of actions that are crafting nodes out of nodes and resources. We're going to have a text document that sits on each location from which you can operate.
Okay.
Okay. The round one is going to be a flat game, but round two is allowed to be a nested game, and you're just going to have a document, a text document that operates from every perspective.
Mm-hmm.
All the stuff inside of it.
All the things that you can access at each
Right.
location or whatever.
Then you also have a text document that is your inventory or whatever you have with you right now. And it's the stuff that you have, it's your character inventory.
Mm-hmm. Sure.
One of those resources is going to be time.
Sure.
And then you can just roll against the universal currency of time at the very beginning when you're doing stuff, but also when you want to move. I want to move this node to this node, and then it's like it's a difficulty of time roll of X.
Mm.
Like it takes some time to move it from here to here,
Mm.
and then
Right.
it's over there. And then when you're accessing stuff in that area, and then it costs some time for you to move from point A to point B. And then once you're in point B and you're in that thing, you can access everything in that node without any time costs.
Sure. Yeah. Yeah.
Does that work and maintain the features that you would want that from the solution that you were providing?
Yeah. It solves the problem of having each node location deal with, because then you don't have to deal with travel costs at each location. There's still the question of
Mm-hmm.
how do you know how much travel cost there is between locations, but maybe that's a higher level node.
So the way I would do it in round one is I would make it flat. So
Oh,
you have
so
an island.
there isn't any travel.
No, no, there is travel cost, but the travel cost from any node to any node is the same.
Okay, sure.
So there's,
I was
and then
thinking
we don't
for
actually know what the
I
island
guess
looks
for
like. It would be like
round
there's a
zero.
town and there's a mountain.
Yeah.
What's that?
I was thinking, I guess for round zero, you just don't have separate locations. You just have one location that has all the nodes.
Right. Correct.
And get that
Right.
working
That's
first.
good.
Okay.
Okay. So putting our attention on one location, we
Mm.
have a text document that's just all the nodes in that location,
Mm.
which is it's a bakery or whatever.
Sure.
And then we're trading against the infinite chaos of adding stuff to your shop, right?
Mm.
So you're not worried about where the wheat is coming from. It's coming from out there.
Mm.
So then we'd have, uh, now I'd have two documents. One is the nodes that are in the bakery, and the other one are the nodes that are present in the game.
Okay. What's the distinction?
The distinction is one you have access to and one you don't. And when you're playing the game, remember it's looking through the list of nodes and presenting you some options of how to trade out this for that and this for that.
Hmm. Oh, so
And then
like
you're
one is your inventory of trades that you've performed already, and resources that you have in your inventory, and the other one is like all the nodes in the bakery or the area that you're in.
oh mm,
Because the
that's not how I would do it.
no, okay. So you're
I
not going
would
to keep a history of trades. You're just going to say like these are the resources that you have.
Well, the nice thing about how Universal Architect seems to work is that keeping track of how many resources you have is the same thing as just keeping track of all the nodes. Because one of the nodes we added was like an example of a node is a transaction,
Hmm.
right? Sell bread minus bread add money. So if I add that node to my inventory, it changes the available resources.
Hmm.
And then you can have like a well, and a well is just adding water. And if I add that node, so then mechanically, what you're doing is you're presenting here's it looks through the list and it spits out five options, and you pick your one of your five options, and the options are just what node do you want to add to your inventory, and you
Yeah.
just keep popping them over.
Yeah. Okay. So then you would be doing the job of the solver that the solver is doing right now.
doing? Hmm, that's a good question. Right, because the thing, yeah, I think you would be actually.
Okay. Yeah. So then you could tell it like auto run and it would just solve it. Or you could be like, I want to do it, and you can, you know, solve it in a different way.
Right. I mean, that is, I think that's the end result of almost everything that we want to build in Fledgling is a
Right.
mechanic where you have the option of doing it yourself or the option of having the computer do it on your behalf.
Right.
Um, yeah,
Okay. So it's like a
because then,
manual solver mode or whatever. Or
right,
you just
and then you
add
can
and
play the, you
subtract.
can play Breadwinner, and we can kind of figure out how it works. And when you and I sit down and play it, we should figure out kind of how it works and how it feels to play,
Mm.
and also how the computer solves things. And then we should, at the end of it, have like an economics module that should function by itself that we can plug into Space Week when we go on to
Mm.
the next kind of game.
Right. Right.
That's my hope, anyway. So yes, a game that we're playing that we're also trying to figure out how to make the computer play automatically.
Yeah. Okay. I'm looking to see if I've got a copy of on this computer. I've got a copy of Universal Architect here. I don't know if I do or not. Hmm.
You can always go to juntsub.org
That's right.
slash universal architect.
Uh, this is all the old versions.
Junts. Okay, so I guess the next question is the idea of rolling on the resources with the 7 resource categories still a good idea for what we're doing here?
Hmm. Okay, so so to do what you're talking about, I think I can just let's make sure. Oh no, this is no, I'm. Oh no, but you're saving this, right? No, I'm broadcasting this.
You are
Junts.org.
broadcasting this.
All right, so I'm gonna go over to here. I think in UA Calc, you can manually call the add node function and just manually add and remove nodes from another node. So I think it's possible to play add resources, remove resources, nested node update. Calc gross, calc entry, calc net.
Oh, I see.
Add or append to sublist. I I haven't worked with this code. Here we go. Add node. Oh no, that just adds it to all nodes list. We need a way to add a node to. I think it's in the resources function. If it's not possible right now, it shouldn't be too difficult to add a function that you could call. So you'd run Universal Architect. It would load in all the things and solve anything you want, but you could just set it to not solve anything. Like you could set up the node list so that nothing needs to be solved. And then you can manually type in the nodes that you want to add and check to see what resources you have available. Right? That would be like the first step, I think, is just make a function that adds nodes to your make like a player node or something that it generates automatically, and then a function that you can call that adds and removes stuff to the player.
So that would look like I'm sitting in my bakery. I have some resources. Actually, okay. problem with our inventory.
Yeah.
I'm sitting in my bakery. I'm looking at my resources.
Hmm.
I have a record of all the nodes. If we are trying to get away from discrete quantities and have uh, qualified, if we want to use our 7 inventory levels
Mm-hmm.
instead of, then you'd want to take any resources that come in and flatten them into just a resource list.
Mm-hmm.
And we don't actually want to keep track of the fact that I have some water and a bit of water and 2 different things. We want to flatten all of
Right.
that into just some water, or maybe have a lot of water with
Right.
a
Right.
bit made it bigger, right? So we'd flatten the whole thing to one amount. I
Right.
think is actually what we want.
Yeah. So we'd need to. I think it would probably be a good idea to keep track of all the transactions you performed, like just so you could have a save game or
Oh,
whatever.
here's what we're doing.
Mm.
So I'm in the bakery,
Mm-hmm.
and the bakery is a node bakery
Mm-hmm.
with all the resources underneath it.
Mm-hmm.
Um, in this case, it's just positive. There aren't any consumptive nodes. And then I think what I'm doing is I'm trying to go over here, and there's another list of nodes, and there's a merge operation that I
Hmm.
want to do where I want to take the transaction node. You know what this is going to end up like? This is going to end up like a bunch of matrices. And then we're combining this node, and we're merging it into this node, and
Yeah.
then resources of the same type are operating on each other.
Or getting
And the
combined together
rule,
somehow.
right? And the game I would be playing is a game where you can't add negative numbers to things you'd already have, right? I can't, because right now nodes can be demand and supply,
Mm. Mm-hmm.
and the whole point is you have a bakery that doesn't have demand in it, right?
Hmm.
Because it's a real object, and the real objects instead of transactional objects are limited by the fact that they have to have positive. They can't have uh, a negative bit of flour in the bakery. It can
Right.
only have
Right.
no flour.
Yeah.
But the bake bread transaction can have negative a bit of flour, negative bit of water, and then you merge that onto your bakery and you see how it modifies.
Mm. I was thinking that you would add the player node as a sub node of the bakery temporarily. So then the
Yes, and
bakery has all the stuff that you have in it
I
in
would
it.
make the player have the same constraints of a real node has positive values,
Mm. Right.
because
Because
you
right
don't
now
want
it's
to
all
walk around
transactional
with,
nodes.
right, and you might have conditions on your nodes, like uh, your spaceship has structural integrity, and if your spaceship ever has 0 structural integrity, it
Hmm.
ceases to be a spaceship, right?
Yeah, it blows apart and all its transactions go away, and you're just left with
Right,
all
the
the
speculative transactions
components.
go away, and it's left with all the components as like debris field, and debris field still has the exact same stuff, but it's no longer a spaceship, and
Right.
then maybe it loses. I don't know.
Right. Oh, yeah, interesting. So yeah, so there needs to be a distinction between concrete and abstract nodes, or like you were saying, transactions and real nodes.
Right, and I think it's going to be just a thing that we are building ourselves. I don't think the math actually has to care,
Hmm. Okay.
because you could take a negotiation between yourself and another party where you're taking abstract nodes and adding them together to make a more and more sophisticated transaction. In which
Mm-hmm.
case, we're adding and subtracting negative things and positive things into a giant operator,
Mm-hmm.
and then at the end we operate that thing one direction on and then you invert it and operate the other direction on the other party.
Mm-hmm. Yeah. That's kind of how it works right now for solving something. Is it's building up a big transaction that is composed of a bunch of smaller transactions. If you're thinking about the nodes right now as transactional
Right.
operations.
Hmm. Um, right, but I'm talking about where we would want to expose that capacity to the player. Um, because I imagine if we build a sophisticated node structure, that Universal Architect is going to be. I'm hoping that we can get Universal Architect to give you interesting choices that already have some solving happen. It's like, well, I
Mm.
already solved for this stuff. Do any of these look like things you want?
Mm. Right. You have
Right?
an
I know you
excess
want
of
bread.
something. Here are some
Right?
ways
You
you
have
can use that.
exactly.
Mm.
Like, and it will. I would try and make it slightly parametric off of the resources you tend to have, and it will focus more attention on things you have a lot of or have none of, or
Right.
something like
You
this. Right?
seem to have a lot of time. Let's solve that problem.
Exactly. But this is how life kind of feels, right?
Hmm.
People who have a lot of time on their hands end up getting into stuff that takes up a lot of their time.
Hmm.
Do you want to watch Netflix? Yeah, yeah. Whereas like I don't feel like watch Netflix is ever an option in front of me because I
Hmm.
don't really have any time.
Hmm. Right. Hmm.
Okay, so the question is, do we um, does round one of Breadwinner even have this rolling mechanic?
Okay, so there's two things that we're trying to do at this point. One of them is taking the abstract transaction node system and adding a layer of concrete real objects to it.
Right.
And the other is converting the resource system from a countable numeric system to a some kind of almost like logarithmic scale numeric system.
Right. Basically, but it's a random type system.
Yeah, yeah. I think that the I think that the numeric solver right now will be able to, if we use numbers, if we use 0 to 7 or whatever,
Right. Right.
that the numeric solver right now will be able to solve for those different values. Like it'll be able to solve it still and say like there's a path from here to there, right? If you ask it like how do I get a bunch of money, it'll be like, well, here's the easiest way to get a bunch of money or whatever it is. Maybe not the easiest, but like given these nodes, here's a
Sure.
path to get from what these nodes give you to having some abstract resource. And then so that would still work, and so we haven't lost that functionality, and then we need to make another system that is dealing with concrete nodes. So we could do both at the same time is what I'm saying. Is you've got your abstract solver that just says, is there a way to get the thing that I am looking for out of this set of resources? And then you've got another thing that says, here's your starting point. You decide what transactions you're going to make, and they're not guaranteed anymore. Now you get to gamble on each transaction. and you have some concrete objects that don't have negative values in them.
Right.
So it's like a parallel,
Okay, so
like two parallel
how would that
things.
how would the solver solve things without? Are we going to have two ways of constructing nodes? One is one where you gamble, and one is where there's some sort of hard rules about how to put it together. If I wanted to make uh, gunship Titania using the rolling system or
Hmm.
the
Well, the
seven,
the calculator wouldn't use random numbers. It wouldn't, because they're not. Then the validity of your system would depend on the random seed, right? Sometimes it's valid and sometimes it's not. So I would just leave it exactly like it is. I would just say there's a, because all then all it's doing is calculating the it's just adding things up, right? Just calculating a valid path through. And the number of nodes that you need isn't actually a useful number. It's just telling you there's a possible way. If you get this much resource, then you can feed it into this thing and get some resource, and feed into this thing and get some resource. So the calculator wouldn't be part of the game. It would just be a tool that we still have access to. So if we end up with a very complex node structure, or if we're adding nodes in the game, if we're adding live while you're playing it, then you can have the calculator run in the
right?
background to validate that the nodes that you've added aren't going to break something somehow. There's still no guarantee that the game is beatable, but it's at least demonstrates that the game is solvable.
Right.
So like if there was no way to get water, if you removed all the nodes that generate water, then the solver could run in the background and be like, hey, that's a problem, and undo your last edit or whatever, and bring back something to be like, you can't remove this node as necessary for the game to function.
Right. Okay, so here's a interesting thing that would occur if we change the solver to roll on all of its constructions. Then every time you built Battleship Titania, it would have different nodes in it around some sort of distribution. Right.
Okay.
This Battleship Titania has 4 engineering crews. This one only needed one because it got really lucky when it got built.
Okay. Yeah.
And then at the output, you end up with two valid, different Battleship Titanias because remember, valid doesn't really make any sense anymore
Mm-hmm.
because everything's random,
Mm-hmm.
and it's just going to be Battleship Titania and a list of its resources in its 1 through 7 quantities.
Mm-hmm.
And this Battleship Titania has a lot of engineers, and this one has some engineers. And we don't know, we probably don't even need to keep a record of why that occurred, but we could. And we just like, it turned out that when it kept rolling, we need to add this and we need some engineers, and we keep rolling against the engineering resource. We still had some.
We still have some left
And
over.
then
Yeah. Yeah.
we still had some left over. So we just kept on rolling against it. Now we have this giant spaceship with all this firepower, and we kept rolling on the system until we managed to get a lot of firepower.
Mm.
And then
Right.
this is what we ended up needing to add in nodes. We had
Mm-hmm.
to add 6 engineering decks and whatever, and then this is our leftover resources. Right? We still have a spare. We have no spare engineering. We have no spare whatever else.
Sure.
But then there's no record of
Each individual
what.
role or whatever.
Right, but then what's left over because the the actual resources are getting consumed. Right now, you open up a cool feature of Battleship Titania. Right now, in you open it up and you know that there are X number of engineers being generated and used up.
Mm.
So
Mm-hmm.
we might have 20 spare engineers, but there's 8,000 engineers being working in the system.
Right. Right.
And with the role system that I'm imagining, you open it up and you say, what's in here? And it says, some engineers,
Right.
right? Some spare engineers. And it's like, well, how many engineers are working in here? It's like, well, I don't know.
All of them. They're all working. or most of them are working. There's some
Most
spare.
most of them are working.
Right.
Um, and that seems like that's disappointing. Like I like
Oh,
the
okay.
feature of the fact that you can
Mm.
open up the other ship and you can find out how many engineers are in there because one of the big parts of the resource management game that you and I talk around is the ability to take something apart into its components and reconstruct it into something else,
Mm.
right?
Sure.
The scrappy A team builds a tank out of spare parts experience is
Mm.
such a good one that I would
Mm.
love to play in the Space Week. You're like you find a wrecked fighter and you like pull stuff out of it and then add it to your ship,
Right.
and that I don't know how to preserve the math such that when you arrive to the fighter, the game can generate a fighter, then break the fighter, and then still have stuff left over.
Mm. Yeah. Well, you
So,
can preserve the net and the gross. Like that's how it does it right now. Is it's got gross and net, and so the gross is just the total that has been generated there, and the net is how much is left over. But with the qualitative, well, and we were talking about this last night too. The qualitative descriptor quantities are only helpful if they have a fixed scope. Because if you take your fighter and you've got all
right,
the engineers on it, and then you land at a city, and now how many engineers do you have on your ship? Well, you have much fewer compared to the city, right? Now, like all the engineers are in the city and your ship, but like what portion? And so, like all your
right.
quantities are changing dependent on context.
Maybe I give up on discrete. See, the thing that's nice about it is it makes the generation of nodes really, really easy.
Hmm. Well, and you could also
Um,
just have a toggle for lucky mode where you always win every roll. You just need one of every resource and you always win every roll. And so you just need a pinch of everything,
right. Uh,
which is also basically the solver, the validating solver thing is just like, okay, well, if I was super lucky, what would I need? Like, what's the chain to get me there? Another thing you can do if we want to really commit to the uh, resource qualitative descriptor system is you just don't allow switching contexts. You're just like you're always operating in whatever the largest scope is,
right.
and you don't have travel
Okay.
costs and you don't have any of that. It's just
Right.
like here's the
Certainly,
island.
round
It's the
one,
whole island.
you should be operating without in within one scope.
Mm.
Okay, rolling on things. What if we kept so Battleship Titania, and we say what is Battleship Titania? If you keep a record of all the nodes, which are now both transactions and like events and everything else, it's like a ledger of everything that Battleship Titania
It's like a captain's log.
has occurred has occurred to it. So like you're keeping a record. It's like got shot by lasers is
Mm.
in the node, right? And you have this giant history of because
Yeah,
like text is cheap.
yeah.
Are we going to run into problems with having like a 10-mile long ledger of what Battleship Titania is?
Well, I mean that's the captain's log kind of thing, right? It's like, well, here's the construction. That's what you do when you calculate like what it is, and then like it was launched, and then here's all the adventures it went on, and things it did.
Right. So then when it runs out of structural integrity and it ceases to be Battleship Titania.
Mm. And then you
What's
take
left
all the
over then to
parts,
scrap?
and then you build it back and you redesign Battleship Titania with all the spare parts, and you rebuild it, and now you have the Battleship Titania of Theseus.
Um, Well, how would we determine what's so if it's getting flattened, couldn't we just like run back through the transactions? Like we have this giant transaction, and then
Mm-hmm.
we tree that had oh no, I think it no weird stuff would happen. Net and gross. I'm trying to figure out what gross quantities mean in our flattened resource paradigm.
Well,
Because if we
if you,
keep on
yeah,
taking, if we take 45 a bit of damage,
right.
right,
How
and then
much
we have
damage is
we
that?
have we now have zero struct we have no structural integrity because
Yeah,
it finally chipped it down,
yeah,
and then we go back through the system and we want to generate how much volume. Look, because like we had volume, which is
mm-hmm,
available,
mm-hmm,
and or it's like when the structural integrity you now have less structural integrity than you have volume, your ship is broken
mm.
or something like this. And then
Well,
if I want to come in as a scavenger and pick up all the scrap, like I want to pick up scrap,
mm,
which is going to be structural integrity, I think. How much structural integrity is sitting around in the scrap field that I can harvest?
yeah. Well, all of it is there, but how much is that?
How much is that? Right?
And I
Or
think it goes
like,
back to having a fixed scope. Like, is this a solar system? And then like this ship
so
compared to the
let's
solar
let's
system only
assume
has a
let's just
bit.
assume a fixed scope of two spaceships fighting each other. Okay, I'm Battleship Titania, and they
Yeah,
are Battleship Oberon, and
sure.
then we're fighting, and then
And that gives you
Battleship
a weird
Titania
situation
blows
where
up
you can damage the other
integrity.
ship by repairing your ship because then the in the scope that you're operating in, you have more of the resource and so they have less.
Well, I don't know why you couldn't both have most, right? You both have because you both just have 6 out of 7.
Yeah.
That seems that doesn't seem to break anything
Hmm.
from the math perspective because it's not keeping track of the percentage. It's just the percentage is to give you the impression as to how much there is,
Yeah.
right? But that still breaks when you change scope anyway. So they both have 6 out of 7 structural integrity. They're
Sure.
shooting at each other, doing a bit of laser damage over and over and over, and
Hmm.
eventually the
One or
they
the
get
other gets
unlucky and
whittled
the
down.
damage actually sticks and it does a point of damage and it does a point of damage.
Right. And
This ends up
it'll start accruing
feeling a lot
faster
like
and
having like a
faster because as one starts falling behind, your rolls get harder to maintain your
correct,
current level.
right,
Mm.
and then it finally breaks.
Right.
Okay, so the question is, Battleship Titania goes over there
Mm-hmm.
and salvages the mess.
Okay.
So now Battleship Titania shows up in the debris field,
Mm-hmm.
which is the node that is the Oberon post destruction.
Mm-hmm.
And I want to ask what's in that debris field and for it to make sense given what Oberon was.
Okay. So
And I
we're
don't know how
already
many
positing
engineers are there,
we're yeah,
and I don't know how.
we're already positing a system that has specially tagged resources that tell the system how to calculate things. Structural integrity, right, is a special resource because it changes the way that the game operates. It's not like any other resource. You can't just trade it away or, like get some. Like once you've traded it all away, then something special happens. The type of node that you're operating changes. So
Um,
as long as we're positing special named resources that have special qualities, we can posit a special resource called like salvage fraction or something that each node needs to have in order to be salvaged. And so like research, like engineers don't have a salvage fraction. They all die when the ship explodes. Uh, Structural integrity, maybe it has some salvage fraction or I would think that the the amount of structural integrity, I would think that the ship would actually break before the structural integrity went to 0, and then each piece would have structural integrity, like some larger portion of structural integrity. So you say, like, the ship breaks apart, and now you've got two pieces, and those are, pretty cohesive because they weren't damaged too much. But like the stuff in between was destroyed, and so then you've got some of the resources in each section, and then some of the stuff falls out into a debris field that has no structural integrity. But anyway, even if it goes to 0 and everything's destroyed, you've still got like engine nodes, right? And like, well, what's the salvage fraction on an engine node? It's 0.3 or something. And so now, it rolls on each engine to see if it's available for salvage, or maybe the number of, but see, like, it's not each engine anymore. No, it's just how hard the roll is to reduce the quantity of each of those things.
So this is what's weird, is it would still, Battleship Oberon would still have its construction ledger of how it was built.
Yeah.
And therefore we'd know how many add engine actions occurred in order to get the thrust up. Right?
Well,
so add engine action modified it so it had more, like, and
no, we don't have
ledger of the rolls that occurred, which still could be a record of going backwards and trying to find out how many things are in the debris field. You could just go backwards from the forward and like, oh, it had add engine action, so now it's broken, and we're saying, do we have an engine node out there? And we can just roll 30% chance per node that still exists, and then the debris field is going to have. If Battleship Oberon got really unlucky and had to have 25 engines added,
you can't. It only goes up to 7. So the way I would you roll to add. I thought you were just rolling to subtract.
Well, the idea would be that you'd have, if you built Battleship Titania twice, they come out differently.
Right. But like, you could do it with just roll to subtract. You say, like, we need some engines for Battleship Titania to work, or we need a pinch of extra thrust. Like a spaceship needs a pinch of extra thrust. And so you add a pinch of engines. So now you've got like 1 engine quantity. And then you start doing things and like, oh, well, we need some thrust for this. Does it reduce our thrust to 0? No. Okay, good. We need some thrust for this. It reduces our thrust to 0. Yes, it does. Okay, so now we need to increase our thrust capacity to 2. And then this thing that we did reduced it to 1 again. So now we still have a pinch of extra thrust. But the gross quantity is 2 now. And then you keep doing this, so you're rolling to reduce, and you always end up with a pinch of extra, whatever it is. All the things that you need have net a pinch. And so then you do
how
get,
this works.
Well, so then you do get different gross quantities. Because you'd have a gross quantity of, a little engines, or however it ended up. And sometimes you'd end up with a lot of extra engines, or a lot of gross engines, but you always end up with a pinch left over.
Right.
Unless you set your margin to larger than that. Maybe you always end up with a little left over.
Okay, we'll have to continue this conversation in a bit.
Okay.
I just got a text message. My son is on the way.
All right.
So I'm going to go meet him. Okay. So
lots to think about.
I got to get my dice.
Cool.
Okay, I'm going to work on this while it's gone. I'm probably going to make some spaceships by paper and see how it ends up feeling.
Fun.
And go from there. Okay.
Fun.
Talk to you next week.
Bye.
Bye.
All right. Thanks for joining us, everybody. I hope that was interesting. You can access all of the code here at jhundts.org, JHUNDTS. Let's see, can I zoom in on that? I can zoom in on the code, but not on the address. Maybe I can do it over here. Here we go. Yes. junts.org/universal architect. So if you go to junts.org, there is a link to Universal Architect. That's what we were talking about today. And you can download UACalc 0.2.py and specification.txt, and that will get you started on... it's off the bottom. There we go. UACalc and specification.txt, and that will get you started on whatever it is that you want to do with this piece of software, this funny little piece of software. I hope that you have a good day, and I will stop streaming now. Oh, and now I'm all zoomed in.